Hi there, and welcome to lesson 2.2 for pre-calculus. So today we're going to learn about polynomial functions. We've been talking lots and lots about functions in general and different types. Today we're going to specifically be talking about polynomial functions. So what is a polynomial? You're familiar with a polynomial. Polynomial function is one that you're familiar with is a quadratic. So let's say we have x squared plus 2x plus 1. This is a polynomial function. It is raised, our leading term here is raised to a power greater than 1. We've got a polynomial function. So anytime we have an exponent greater than 1, you're talking about a polynomial function. And in general, polynomial functions are going to exist for every single x value. They're going to be continuous. So any value of x, we're going to have a value of y. They're also going to have these curves like this, and there might be multiple curves depending on the power of that exponent, depending on whatever this n is, the highest number for our exponent. Okay, so you don't need to write all of this part down. The more important stuff is going to be later on. So let's move on to the next slide. So we've got two graphs here. Both are of parabolas, and we know that these are parabolas. We know that they're quadratic functions. So what do we notice here about the ends of the graph? And what I mean by the ends are right here. So on this one, we see that they're both rising up. They're both pointing upwards. And on this second graph, we see that they're both pointing downwards. So on the next couple of slides, we're going to learn how we can predict what's going to happen and what those ends, the left-hand side and the right-hand side. So this would be our left-hand side over here and our right-hand side over here. What they're going to do. Are they going to be increasing? Are they going to be rising like this graph where they're pointing upwards? Or are they going to be falling like this graph? Or are they going to be doing different things? One's going down and one's going up. So let's find out how we can figure that out. Okay, moving on. So what you're going to learn now is the leading coefficient test. And what this is that we're going to take the leading term. Now remember, for polynomials, for all polynomials, you want to write them in descending power order. So we see that x squared, our 2, is our largest exponent, and we write them down in descending order. So this is your leading term, and this is our leading coefficient. So if n is even, and you can see I have them color-coded here. So if we take a look here, our orange number, so if our highest degree of our polynomial is an even number, and our coefficient right here is bigger than 0, then both the left hand of the side and right hand of the side of the graph will rise. And we saw that in the parabola previously. So if we were to take, for example, the equation y equals x squared, we know that that graph looks like this roughly. And take a look at our left-hand side. It is rising, it's pointing up. And our right-hand side as well, also pointing up. So for any even degree polynomial, so any even degree could be x squared, this could be to the 4th, to the 6th, to the 10th, to the 100th. It does not make any difference. If this is an even number and this term right here is positive, is bigger than 0, both the left and the right hand side are going to be pointing upwards. They rise. Similarly, if n is even, so we're keeping it as an even function, but we've got a negative 3x now. So here we see that our negative showed up. Then both the left and the right hand side will fall. And we've seen that before when we've had y equals negative x squared. We don't see the 1 here, but technically our leading coefficient would be a negative 1, and our graph looks like this, where both the left hand side and the right hand side are pointing downwards. They fall. And again, that's going to happen for any even function. Both the left and the right do the same exact thing. Okay, so we've been talking about even functions, but we know that's only half of them. What about odd functions? Okay, well, we've got some information about those too, so let's move on. So now we have a function that's to an odd power. We can see that right here. Our highest exponent is odd. So if n is odd, if our exponent is odd and our coefficient is positive, the left-hand side of the graph falls and the right hand of the graph rises. And we've seen that before too, when we graph y equals x cubed. Remember what that parent function looks like? It looks something about like this. So see how our left-hand side over here is falling, it's pointing downwards. And our right-hand side is rising. So if it's odd, first they're going to be doing two different things. Think of it as being odd, being different. They are doing different things. The left-hand side is not doing the same thing as the right-hand side. And this function is going to start off where the left-hand side falls down and the right-hand side goes up. So what do you think is going to happen now if we have a negative leading coefficient? All right, you probably guessed it. If n is odd, so we've got n still being odd, it's to the third power, but we've got a negative right here. So our 2 just became negative. The left-hand side now rises. Before it fell, now it's rising. The right-hand side is going to fall. So they still do different things. No matter what, if it's an odd function, the left hand is going to be different than the right-hand side. So just think about it being odd, it's a little bit different. Even, doing the same. Odd, doing something different. And we know also from that if we were to graph y equals negative x cubed, our graph would look like this, where our left-hand side is pointing upward, our right-hand side is pointing downward, just like this says. And this is true for any polynomial that has the highest power as an odd number. So 3, 5, 7, 11, 99, 101. Any polynomial whose leading power is to an odd number, the left-hand side is going to be different than the right-hand side. If a is positive, it's going to start falling and then go to rising. If it's negative, it starts rising and then it falls. Okay, so let's take a look at some other polynomials, some general ones that we have here. So what we're going to learn about now are monomials, and these are known kind of commonly as your power functions, where you just have x raised to a power, or maybe it's like x plus 1 to a power, x plus 1 to the fourth, something like that. We could have a function, that would be a power function, y equals x plus 1 to the fourth, where everything is raised to the same power. So we know x squared. We've seen this. This is our general parent function for x squared. We've also seen x cubed. These should be very familiar. They shouldn't be surprises at all. So what happens when we have x to the fourth? It looks very similar to x squared, but notice how it kind of flattens out here. So the larger that this number gets, the flatter this part right here will get. And this is only when it's raised to a power, when the whole entire thing can be written like this form. So this gets flatter. The same thing's going to happen when we get x to the fifth. This part right here squishes out more. It becomes a little bit flatter. And the higher degree you're going to go, the flatter this middle part's going to get. So those are your monomial functions. Now let's take a look at when we have multiple zeros of the functions. And I know I'm moving a little bit fast here, so feel free to pause if you need to copy down the graphs. Okay, so moving on to the next one. What if we have multiple zeros? Those graphs are going to cross at multiple places. So parabola doesn't do too much. We've just shifted this parabola down a little bit. But what do you notice about this? So we have, this is just your parent function, by the way. This is not the actual function of the graph. This is just the parent function. So here we see that this crosses the graph at two places. There is no coincidence that we have two intersections and our power is to 2. That is the maximum number of zeros. So the maximum number of zeros a function can have is the highest degree. Of the function. So we have x squared is the highest degree too. We can only have 2 zeros. Okay, so here we have a cubic function. Now remember, previous slide told us that a cubic function is going to start with our left-hand side decreasing or falling and our right-hand side increasing. Remember, whereas the even function, both sides are going to be doing the same. And if a is positive, which in all of these cases, a is going to be positive in my examples right here, both sides are increasing. They're rising. Here, we've got the left-hand side is falling, the right-hand side is rising. And also, we see that we have 1, 2, 3 zeros. That's the most amount of zeros that a function can have if it's raised to the third power. Okay, what about x to the fourth? So remember, this is an even function. This looks a little different than the previous slide. This now has more zeros, multiple zeros. We have 1, 2, 3, 4. And also, it changes direction 3 different times. So that is, we know that it's going to be staying the same on both the left-hand and right-hand side. And we can see that it can change direction many times now. This changed 2 different times here. We went here, changed direction, changed direction. So we started going down, now we changed again, now we changed again. So the higher the power, the more times it can change direction as well. And x to the fifth, we have 5 different times now where it's got a 0. 1, 2, 3, 4, 5. Remember, it's starting as a falling graph. The left-hand side falls, the right-hand side rises because it's raised to an odd power. Okay, so those are just your general characteristics of polynomials. You're getting an idea of what these graphs can look like and how they can change depending on how many zeros they have and what the changes of directions look like. So let's move on to an example here. We got to figure out what kind of graph are we looking at. So we have to figure out, first of all, is this odd or even? Okay, we got this, no problem. We see our left-hand side is falling. This is going down. Our right-hand side is rising. They're doing 2 different things, so therefore we know it's odd, because if it was even, they'd be doing the same thing. We also know since it's starting off with the left-hand side falling, our leading coefficient, a sub n, is going to be greater than 0. We also know that this probably is a degree of how many different, let's count how many zeros. 1, 2, 3, 4, 5, 6 different zeros. So we know it can't be to the 6th power because it's to an odd power. However, it could be 7 zeros because we know it can't have more zeros than the power. So this could possibly be our power is 7 or higher. So without even knowing what this function actually is, we have quite a bit of information about it from the previous slides. That's all we need to know. Okay, so that is it for today. You learned a lot about polynomial functions and how you can tell about their graphs. I hope you enjoyed this lesson and see you all soon. Take care. Bye-bye.